Okay, so this is to do with the math section. Okay, so this is the bit that most people struggle with. Okay, so this is about relative formula mass. Okay, so I'm gonna answer these questions. So the question is, what's the relative formula mass of A, B, C, and D? Okay, so I'm gonna do them all separately. Now, before we start, we need to understand what these mean. So what this means here, this CuSO4, is that there is one copper atom. There's one sulfur, and there's four lots of oxygen. So if we're gonna work out A, the first thing you need to realize is that it's formula mass. So it's looking for the total mass number. So what I'm gonna do, I'm gonna get my periodic table out, which is here, and I'm going to. So where's that opacity thing? I don't know. Oh, there it is. So first thing I'm going to do, it's CuSO4. So I'm going to look for Cu. Here's Cu. The mass number is the number at the bottom. So in the case of Cu, I believe it's 40. Sorry, it's not the bottom number. It's the mass number, which is the top number. Okay, so I need to go to my periodic table. It's not very clear on that periodic table, so I'm going to find this periodic table here. And Cu is 63.5, sorry. So copper is 63.5. Right. Sulfur, let's find sulfur has a mass number of 32, which is the top number. And finally, CuS and O has a mass number of 16. So now it does make sense, guys, where the mass number is the top number, it's the heavy number, because obviously you want the mass number, so you want the heavy stuff. So like we said, there's one of these, so I'm gonna write 1 times. So what was Cu? It was 63.5, 63.5, and I'm gonna add that to how many sulfurs do I have? 1 times. Now, guys, in your scientific calculators that you will have, don't forget to include the brackets. Okay, so it's going to be 1 times sulfur, which is 32. Now I've got 4 lots of oxygen, so I'm going to write 4 times the mass of oxygen, which is 16. Right, then you do that in your calculator, so it's going to be whatever it's going to be. So that's going to be oh my goodness, I should have worked this out beforehand, but it doesn't matter. Let's do it together. That's 24. 4, 5, 6, so that's 64 there in total, plus 32 plus 63.5. So if we add these together, let's add them together. 63.5 plus your 32 plus your 64, this is obviously 0.0, so it's going to be 5.9, 12, 13.15, so it's 159. So the total molecular or formula mass for this is 159.5. So that's that done. Let's do the next one. Let's go with B. Now with B, we're doing Fe2O3. So what you need to realize is that there are 2 ions and 3 oxygens. So if we're going to work out B, guys, if you want to have a go, pause it, have a go, then see if you're right. So I'm going to write Fe2O3 because that's the question. O3, and I'm going to write 2 times Fe, so I'm going to get the formula mass from the periodic table, remember, and so it's a transition metal, it's from the middle block, and it has a mass number of 56, so it's 2 times 56 plus 3 lots of oxygen times 16, and I got this from the periodic table again, it's the top number, the heavy number. So 2 times 56 is 2 carry the 1, 10, 11, 112 plus 6, 12, 18, 8, 1, 3, 48. So 112 add 48 is going to be 0, 1, 4, 5, 6, 160. So that's the formula mass of Fe2O3. Let's do C now. So again, you need to understand what the formula is saying before you can solve it. So C, here it's saying you've got an Fe, so you've got 1 ion, and you need to multiply the inside by the outside. So I've got 3 oxygens because 1 oxygen times 3 is 3, and I've got 3 hydrogens, so that's what you need to remember. So what I'm going to do, I'm going to write this down, Fe brackets OH close brackets 3. So I've got 1 times iron, so I need to find iron in my periodic table. It has a mass number, that's the top number of 56, plus I've got 3 lots of oxygen, so I need to say 3 times 16, plus I've got 3 lots of hydrogen, 3, and if you look at the mass number of hydrogen, it's 1. So now I need to solve this, so this is 56 plus 6, 12, 18, 8 carry the 1, 3, 48, plus 3. So let me do that here, because I'm not good at arithmetic, so I need to show my working out. So 8, 9, 10, 11, 17, 7 carry the 1, 5, 4, that's 9, plus this 1 at the bottom, that's 10. So this has a formula mass of 107, we just worked it out. So next we're going to do aluminium nitrate, which is D. Okay, so let's have a look at D. Again, before you can do this, you need to understand what it's showing. So if I write down D, so what you got to realize is this is aluminium, so I've got 1 aluminium, I've got, remember you have to multiply the inside by the outside, so I've got 3, because this is the number 3 here, this is the number 3, and I've got 3 nitrogen, so 3 times 1 nitrogen, that gives me 3 nitrogen. Now 3 times 3 oxygens, because I've got 3 oxygens already, that's 9 oxygens. So this is what I'm going to do. I'm going to say AlNO3 3. So let's do this. What's the formula? The mass number for aluminium. Aluminium is 27, so I've got 1 aluminium. I'm going to times that by 27, plus I've got 3 nitrogens because I'm timesing it by the outside. 3 times nitrogen, the top number is 14, plus 9 because I've got 3 times 3 oxygens. 9 times 16, I'm going to add them together, so I've got 27, add 4, 8, 12, that's 2 carry the 1, 3, 42, plus so that's 54, 9, 10, 11, 12, 13, 14, 144. So if I add up these numbers, I've got 144, add 42, add 27, which is 4, 5, 6, 13, 8, 9, 10, 11, 1, 2, 213. That's the formula mass for aluminium and nitrate. Okay, so I'm going to stop this here and I'm going to do the next one separately, okay, which is empirical formula. I was thinking of doing it in the same, but I'm going to do it differently. Okay, I'm going to do it on a different video.